Hello class, we're going to go ahead and start section 2.6, special functions today. One of the essential understandings from this chapter is that students can determine between linear, step, absolute value, constant, and identity functions by looking at their data, function, or graph, also being able to graph absolute value functions. So our learning target for today is exactly that you should be able to depict from a graph the type of function, including absolute value, piecewise, and step functions. Knowing the difference between these functions is going to be important, not only in Algebra 2, but in any math class you take after this. All right, so it brings us to the first problem at the top of your note sheet. The cost of postage to mail a letter is a function of the weight of the letter. It says, is it a linear function? Why or why not? So we're looking over here at the mailbox, and it says weight, not over. So what it means is the answer for if it's 0.5 pounds, it's still going to cost you 39 cents. If it's 2.5 pounds, well, can't be over 2, so it means you have to go to round it up to 3, so it's 87 cents. So is this one linear? It is not linear. And the reason is because there's no in-between charges. You can't have half an ounce. And another way of saying that is because it's not continuous. To be continuous, it would include everything. 1, 1.1, 1.01, 1.0001, and everything in between 1 and 2, but this does not. So it is not continuous. And since it's not continuous, it has breaks in it. Okay, so it's going to be a step function. So we're going to talk about that in a minute. So it says, what is the cost to mail a 1.5 ounce letter? Well, 1.5, it can't be over 1, so that means we have to go to 2, so that means it's going to be 63 cents. Okay, if we go on, this is a step function that we were just looking at. Okay, so a step function is also referred to as the greatest integer function. And here's what it looks like. It's f of x is equal to, and that looks like double brackets on both sides. So that's your step function. That's what it looks like. On a table, okay, it's saying your x values, it can be between -3 and -2. And the output in between there is -3. Okay. From -2 to -1, the output is -2. So anything in between there, since we cannot be above it, okay, has to be rounded up. Okay. Or in this case, if you look, it's rounded down. So if I'm 1.5, looking right here, 1.5, it's going to be just 1 because it's in between 1 and 2, but not equal to 2. If you were to graph this, this is what it would look like on the graph. Dot means that the point is included in the graph. We've already been doing inequalities, so same thing. If it's included, solid circle. Let's just go ahead and look at this part right here. Okay, it's for the box I already was highlighting here. So it's saying from 1 to 2, the answer is always going to be 1, or your output will be 1. So it's a solid circle at 1 because it is equal to, and it is an open circle because it is only x is less than 2. There's no equal to. So it's not included. So just some things to point out. The symbol means the greatest integer function, greatest integer less than or equal to x. So if I go ahead and look at the greatest integer of 7.3, well, this means less than or equal to. So if I was looking at it according to my graph here, well, if we had 3.3, we would round that to 3. So 7.3, we're going to go ahead and the answer is 7. Here's another one. It's -2. Since it's negative, it can be a little tricky, but we can use our table up here to help us. If you look at the top box, -2.4 is in between -3 and -2. So if my number is in between here, my solution is -3. The next function we're going to talk about is the constant function. We've already looked at this a little bit, but constant function, the reason it's constant is because it's staying the same value throughout. Some things to note is that your slope is 0, which means that there is no slope. Typically, just so you notice, this is horizontal. If you have a hard time remembering the difference between vertical and horizontal, remember horizontal goes with the horizon. So from left to right. And then lastly, if you were to write the equation, it's going to be y is equal to some number, and that number is your constant. Okay. The next function we're going to look at is the identity function. The identity function, it does have a slope. It rises 1 over 1, rises 1 over 1. So my slope is 1 over 1 or 1. My y-intercept is 0. And the equation for this one, it says f of x is equal to x. So remember, f of x is the same as y. So it's y equals x. It's the identity because whatever you plug in, you will get out. If I plug in, let's see, if I plug in 3, I'm going to get out 3. If I plug in 4, I will get out 4. So it's the identity because no matter what you put into it, you're always going to get the same thing back out. Then the absolute value function looks like a V. So you guys know how to take the absolute value. Remember, it's distance, so the value always comes out positive. So if I go ahead and I plug in -3 to the absolute value sign, I will get 3 out. If I plug in -2, I will get out 2. If I plug in -1, 1. Plug in 0, you get out 0. Then it's just going to be the same. And if I were to plot all these points, so -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, I would get this V-shaped function. Okay. One thing we need to talk about a little bit is domain and range. Domain and range. We talked about it last week. Remember, domain is your x values. So when you're looking for domain, you're going to look from left to right. Okay. Well, if you look and see, these arrows show that it is going to be continuing on forever to the left and forever to the right. So that means we're going to cover every possible answer. So that is what we say that it is all reals. And we like to make an abbreviation. This fancy R is how you would show all reals. Now range, so this is your domain. Range, you look from the bottom to the top for range. Okay, so I look, what's my lowest y value? Well, my lowest y value is 0. What's my highest? Well, if you notice, it's going to go from 0 all the way up and keep going to infinity. So it just says that y has to be greater than or equal to 0. That would be my range for my absolute value function. And let's go ahead and look at a piecewise function. Okay, piecewise function is a function that can be written using 2 or more inequalities. If you notice, it has these brackets. That's a good sign that it is a piecewise function. So you just need to use the if part to decide what you use. So if x is less than 0, I put in -x. If x is greater than or equal to 0, I put it into x. So -3. It is less than 0, so I'm using the top equation. So I would do -3, which gives me 3. Same thing, -2 is less than 0, so I do -2, which gives me 2. I plug in -1, it's less than 0, so I would do -1, which gives me 1. 0. 0 is going to be using this equation because it's equal to. So I just say, well, x is 0, and then 0. Same thing with the rest of these, is just going to be the identity. Then we would go ahead and plot. So I would have -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. And what function does this look like? It is a piecewise because the way they wrote it, but it looks like the absolute value. And let's go ahead and look at the domain for this one. So I look left to right. My arrows show that I'm going to keep going on in all directions forever, so it is all reals. And my range, I look from bottom to top. So my lowest y value is 0, right here, and it's going to go all the way up to infinity. So it's y has to be greater than or equal to 0. And the reason I use y is because your range is your y values. Let's go ahead and look at example 2. This is an absolute value function because it has the absolute values. Something to take note of, okay? What's inside the absolute value with x shifts the vertex to the left or right, okay? What's inside, and is always opposite. If its number is positive, it shifts to the left. If it's negative, it shifts to the right. So inside, it's always the opposite. The number outside the absolute being added or subtracted moves the vertex up or down. If it is positive, move the graph up and vice versa. So if I go ahead and look at this one, inside the parentheses, it looks like it's adding 1. So you always think opposite. So if it looks like it's being added, it's actually going to the left 1. And then this plus 2 is exactly what you would think, and it's moving it up 2. We're going to go ahead and make a graph, or a table, and then we're going to fill it in and see if it actually does shift it to the left 1 and up 2. So what I want is for you to do the numbers -3 all the way up to 3. Plug in x for each one and get an output, okay? And graph it in the y column, or plot it in the y column, and then I want you to graph your ordered pairs, okay? So I want you to do that on your own. So go ahead and plug in each value and then graph all of them onto the graph. And then we will finish up the rest tomorrow in class. So have a good night, and I will see you tomorrow.